Okay, in today's lesson we're going to look at interest-only loans. So an interest-only loan is when you can borrow from the bank and to maybe purchase something. So often it's like an investment, or say like a house that you're not going to live in, you're going to rent it out. And so you don't really, because in the future your house is going to cost more than what you bought it for. So you don't want to necessarily pay it off. You're just going to hang on to it until you're going to sell it, and then you'll sell it and you make your profit. So when you're doing this, it's ideal maybe just to only pay the interest of the loan, because you're not trying to pay it off. You're just wanting to pay for borrowing the money. So what happens is the interest that gets charged every month is going to be the amount of your payment. So with the interest-only loans on our formula sheet, you can see we're going to have a recurrence relation situation that we can set up. So we can see it's like other loans. So here, so this big R value will have the interest being charged into it, and so that's going to increase the value of the loan. And then this that will incorporate the interest, and the D value is going to be the payment. Now it's going to be the same amount as what the interest is, so that the total of the loan remains the same amount. So if you have a look up here, we've just got a scenario here. So say you borrowed $1,000 here, you had $1,000, and here is the interest that's getting charged. So it's getting charged 5% every period, and then you're going to take, and so it's getting charged that, but then you're making this payment of $40. But if you look at it, here you can see that the amount that the loan is, the value after every payment, it's still increasing. So this is not an interest-only loan. This is when your payment isn't enough to even cover the interest, so it's still growing your investment. If you look at this next one, so you can see that if you borrow $1,000 and you're getting 5% per period. So 5% is $50. So if it increases by $50, but you're making a $50 payment, you can see that it never changes. So this scenario is an interest-only loan. So you're only paying the interest only. If the payment gets more than that, so you can see here when you're paying 60, you're reducing the loan. So this is reducing amount owed, and so that's like a reducing balance loan. So this is the scenario here is what we're going to look at, and we looked at using Finance Solver now for our loan situations in our last lesson. So when you have Finance Solver, remember PV is the amount that you borrow or you loan. So say for this example here in the middle, your PV, you would be borrowing $1,000 from the bank, and so and it would be a positive. So say you were trying to work out what the payment was, so that was your question. You know, with an interest-only loan, your FV, your final value after one payment, is always going to be the same. So you're still going to always owe the same amount as you borrowed. So you can see here that your FV and your PV are the same amount, except for your FV is negative and your PV is positive in an interest-only loan. So that's mentioned down here on your summary sheet. It says PV positive, and that the FV is the negative of the PV. Okay, your payment will be a negative number because you're going to pay the bank back that amount to keep you paying back the interest amount. Okay, so when often we're trying to find the payment, we just write for one period because we know that the value is never going to change. So we can put N1 and we can pop in FV and PV into our Finance Solver. So let's go and have a look at an example. So Jane borrows $50,000 to buy some shares, because shares are another thing that you might often use interest only. So this is going to be your PV. So I often go through that. She negotiates an interest only loan. So these, remember, always important that we're highlighting what we're looking at. So we know what formulas we're using, and this is important for the interest only. Now for this amount, the interest rate is at 9% per annum. So this is telling us our rate per annum. So it's 9% per annum. And we know in our finance solver, that's our I value is going to be 9. Then it's compounding monthly. So we know that's telling me PPY is 12. And what is the monthly amount Jane will be required to pay? So really they're looking for the payment. So if we go into here, we've done it in our finance solver, it's been cut off. So N would be 1. So it's there, written there. And then we put the percentage rate per annum, and we can see that we've got a PV of 50,000 and our FV is the same but has a negative. Now because it said monthly, that's why we got PPY is 12, and we know for our cases that our CPY is just always the same. So really we're just looking at what this is, and that remains the same. So you would have filled in everything else, and this is left blank, and you press enter and you'll get that answer of 375. So it says negative because you've got to pay the bank. But when they ask you what is the monthly repayment, your answer would obviously be the payment is 375. Okay? Okay, so here's another example we'll go through. So Stuart borrows $180,000 to buy a house. So this is my PV and he's borrowing, so that'll be positive. He negotiates an interest-only loan. So really important, we're seeing that. So we know that interest-only, that tells us that PV equals negative FV. So we know that. Okay, for this amount. And the interest rate is 7.6 per annum. So there's my rate, compounding fortnightly. So if we're compounding fortnightly, we have 26 fortnights in 1 year. So PPY is 26. And what is the fortnight payment? So that is my question, to the nearest cent. So we often do 2 decimal places in finance anyway, and that's another way to say that. All right, so we would be looking at finance solver. So sometimes it's good to write down on the paper. So it's interest only. So we're going to just find out what one payment is. So after one period, and we've got an interest rate of 7.6, and I borrowed 180,000. My payment, that's my question, and FV is going to be the same as my PV but negative, and my PPY is going to be 26. So you would go and pop that in on your calculator. Okay, so you've seen that I've popped all that in, and here is, and I can see that my payment is there. So I'm going to say the payment for this interest only loan is going to be 526.15 cents, so 0.15. She will. Okay, so in this one, this is from the exam. So Shirley would like to purchase a new home. She establishes a loan for 225,000. So there's my PV, with an interest charged at 3.6. So you can either put the I or the R per annum. Compounding monthly, so PPY is 12. I just like to add those things in. Now each month she will pay only the interest charged. So this was an indication to say that this is an interest only loan. So they didn't really say that it was like straight out that it was an interest only loan, but they said if she's only going to pay the interest, that means an interest only loan. So it says after the 3 years, the amount that Shirley will owe. So the amount that you owe is known as the FE in Finance Solver. And now we know with the interest only, this remains the same for interest only. So it doesn't matter it doesn't matter how many years that you have the loan, you're still going to owe the same amount, so which was originally 225. So there's that answer there. Let VN be the value of a Shirley's loan in dollars after N months, a recurrence relation for the model. So I've gone to my formula sheet, and this is my interest only recurrence formula. Okay, so it shows me how to set it up right there. So you've got to have the VO. So the VO is all 225, and you can see all of them have that. So that's pretty different, the same. Now, we're also going to see, we're going to have the R value, which we can work out. So the R is going to be 1 plus the rate, which is 3.6 over PPY, which is 12 over 100. And you're going to get what the rate is. So you'll get the rate to be 1.003. So if you look down there, there's two of them that have that, this one and this one. But you also have to, in your recurrence relation, you have the D value that you're going to minus, because you're going to minus what interest is earned. So we can see here the formula to work out the D payment, which is R over PPY over 100 times VO. So if you did that, it'd be the 3.6 over 12 over 100 times the 22500, and you're going to end up with 675. Sorry, there was a third one there with the 0.003. So here's our answer. We can see we've got the two things that we need there. So D is our answer.